Domain of dependence becomes a very important topic when we discuss numerical method. Either you want to use a explicit methods for your numerical solution, or you want to use implicit method. It all depends what is your domain of dependence. So let me just go back and talk about the advection equation first. We saw that when u bar, which is the velocity of the fluid or tracer or anything, if u bar is greater than 0, then the fluid moves from left to right, and we understand that that q, it can be q can be a density, pressure, or anything. That q actually moves on the characteristics. This is one characteristics, this is another characteristic, so on. So if we have a system of equation like we saw in our previous videos, and we want to see if if we have a point in xt plane, if this is x, this is t, or you may say small x and small t, it doesn't matter, x and t, we make it x and t capital. And suppose that you have a system of three equations. It means that you have three waves and there are three characteristics. Three equations, three characteristics. So we want to see how this point can be affected from the characteristics. Suppose we have one characteristic like this, another one is like this, and the third one is this characteristic. And we know that if we are at point x, then the next point will be x depends what we have, the velocity is positive or negative, x minus u bar t. That will be another point where we have another characteristic. Okay, suppose we have this x naught, and the neighbor point will be x naught minus u bar t. Similarly, if we have three characteristics, this is first characteristic, second characteristic, third characteristics, it has roots on the x-axis. What we see, this is x, this is t, and we want to see how this point is affected from the points on the x-axis. So the first point, this point is x minus lambda 3 t. So we write x minus lambda 3 t, and then we have x minus lambda 2 t, and this point on the x-axis is x minus lambda 1 t. We must understand that there are three eigenvalues, and we understand that there should be some value of lambda 1. If the lambda 1 is less than 0, then we have this negative slope. This is the negative slope, negative slope. And when we have lambda 3 greater than 0, then we have positive slope. Lambda is eigenvalue, remember that, and this corresponds to the over problem in advection equation. Now, the question is, what is domain of dependence? It means that how this point is affected from these 3 points. This point depends only, since we know that the information travel on the characteristics. So whatever we have value over here, for example 2, then this 2 will be transported on this characteristics to reach at 2. The value of q will be 2, so on. If this characteristic, for example, this point has value 3, then this 3 will be reach at point P, which is xt. Similarly, if this has value, for example, 10, then this 10 will be traveled on characteristics, and we get this point, this 10 travels on this characteristics and reach at xt. So what we learn over here? We learn that this point depends only the values between these 3 points. It depends on these 3 points. This is called the domain of dependence. So in this case, domain of dependence is domain of dependence is x minus lambda 3t, x minus lambda 1t. That will be the interval where we have dependency of this point on this interval. If we have something, some point over here, then that point is not affected by that until we have dependency on that. Okay, so this is the concept of domain of dependence. It is very important concept. As I mentioned earlier, this domain of dependency gives us or maybe we can decide whether to use explicit method or implicit method. Thank you for watching.